Hi guys, this is instructional video 8.2, work and energy. We are going to focus on power for this one. So take out your notes and fill them in as we go along. So power and work are related. The difference is for power, it's the amount of time it takes to do something. Now, because they're related, you have to be careful not to kind of mess them up and get them confused with each other. So power is the amount of work done over a period of time. So let's say you're going to run up a flight of stairs and then you're going to walk up a flight of stairs. The same amount of work is being done because work is force and distance, right? So the flight of stairs is the same distance and the force is how many pounds is pressing down on you. That doesn't change. But what does change is the time it takes you to go up the stairs. So running is going to take up less time than walking. So less time means more power. It's more difficult to run upstairs than it is to walk up. So that makes sense. So when the time is shortened, more power was used if it's the same amount of work. So here's how we're going to calculate this. Power is work over time. And I'm going to pull this up. If you like using triangles, triangle is going to be like this. Okay, so work is going to be at the top again, and power and time are at the bottom. So power is work over time. And recall that work was distance and force, or force and distance, it doesn't matter. Okay, so work is force times distance, or distance times force. So this is how these two are related and also different. Work is going to be in joules, just like in last time. Time is going to be in seconds, and power is in watts. Try not to get watts and work confused. So let's try this. It takes 100,000 joules of work to lift an elevator. If this is done in 20 seconds, that's my time. What is the power during this process? Okay, so power, that's a B. Power is work over time. Okay, so here's my work, here's my time. You put it in your calculator and you get that many watts, W being watts. It's very simple, but it's different. You can't get this confused with this one. All right, let's try another one. So John is rowing across a lake. He's going to do this many joules of work in this amount of time. Okay, so if we go back to our previous, power is work over time. Okay, so work over time, and you get 66 watts. All right, number 2, every 8 seconds. So 8 seconds is our time. This is our work. Power is work over time. I'm going to just redraw this. Okay, power is work divided by time. Again, same thing, and you get 9,000 watts. One more, a mechanic does this many joules of work in this many seconds, work divided by seconds, and that many watts. W is watts. All right, now let's practice when you have to combine some things. Okay, so Anna is going to walk up the stairs to class. She weighs this many newtons. That's my force. So remember, work is force times distance, or distance times force. And then power is work over time. Okay? So if Anna walks up the stairs, she weighs this many newtons. That's my force. And the stairs goes up 3.25 meters. That's my distance. It says calculate her power if she climbs the stairs in 12.6 seconds. Well, first, we have to calculate work. And to do that, work is force times distance. So again, here's my force, here's my distance. I'm going to multiply them out, and I'm going to get this much work. And how did I know that I needed work? Well, I can't calculate power without this W here. Okay, they're going to give me time, but I at least need one more variable. So I can't immediately calculate for power without knowing what work is. All right, so now it says calculate the power output if she climbs the stairs in 12.6 seconds. Well, I can use the work from the previous. That's going to stay the same. And now I'm going to say power is work divided by time. So here's my work, here's my time. We're going to divide that out, and we're going to get 146 watts. Well, B says, what is her power output if she climbs the stairs in 10.5 seconds? Well, maybe she's running now, or maybe she's just going a little bit faster. The work is still the same. So I'm still going to use that same amount of joules. I'm just going to change what my time is, my denominator. Okay? So again, same work. She's still climbing the same set of stairs. It's just her time is a little bit faster. And notice that there is a greater power because she did it in less time. Remember, same work, but less time means more power. All right, now let's try this one. It says you exert a force, it's telling you that the force is here, to push a box of books 12 meters, that's my distance, across the floor in 20 seconds. What is the power output? Well, what do we have to solve for first? Work. And again, drawing my triangle, work is force times distance, and for power, it's work over time. Okay, so first we need to solve for work using force times distance. So here is my force, and here is my distance. So 60 times 12, and we get work of 720 joules. Now I can use this, okay, and solve for power because they gave me time. So again, you have to solve for work first. You can't immediately solve for power. And so power is work divided by time. That's my work from the previous problem. This is the time they gave me right here. And I'm going to divide and get 36 watts. Okay? Let me know if you guys have any questions, and good luck.